Welcome once again to Chemistry Mail. Today on Chemistry Mail, we are still looking at chemical equilibrium, and we are on part 2 of chemical equilibrium, where we are going to look at Chatellier's principle. Remember, you need to subscribe to our YouTube channel and follow us on Facebook. Make sure you share our videos to help reach other people. Alright, now like we said in our last video, we are going to talk about a principle that will help us to explain the factors that affect a system in equilibrium, and that principle is Chatellier's principle. So without taking much time, let's explain Chatellier's principle. Let's state what Chatellier's principle is all about. So Chatelier principle states that if an external constraint or disturbance, if an external disturbance or constraint, you may use a textbook that's used the word constraint, is introduced or imposed on a system in equilibrium, the equilibrium position will shift or adjust itself in order to cancel the effect of the disturbance. Wow. So the Chatellier's principle states that if an external disturbance or constraint is introduced or imposed on a system in equilibrium, the equilibrium position will shift or adjust itself in order to cancel the effect of the external constraint. So when a system is already in equilibrium and suddenly a disturbance, something is now disturbing the system that is in equilibrium, what the system will do is to do what? Shift in order to cancel the effect of that disturbance. Imagine if you are relaxing and someone is just trying to disturb you. Maybe the person is touching your ear from the back, and you continue to suffer the disturbance. You will be turning your neck from time to time. You don't know who is doing it. That's an external constraint that is trying to disturb you, that is trying to distort your state of equilibrium. You are balanced, but constantly turning your head like this will actually destroy your balance. So what will you do? All you need to do in order to cancel the effect of that constraint will be to do what? To shift to another position. Yes, that position, as far as that position is concerned, if you continue to be there, that disturbance will continue to have effect on your equilibrium. So what will you do? You shift to another position and re-establish your equilibrium. Yes. So let's go further in explaining this. If you are giving, Christmas just ended, and most times during Christmas people eat and overeat. Imagine if you are given a plate of food, a plate of food, and you have let's say the common food that everybody eats. You have rice, just like a mountain. You have rice. No other days when you want to eat, your rice will just be like this. You are okay with it, you just say a little. But I don't know what normally happens during Christmas. People will always say, please make sure that the food fills every part of the plate. Then we have assorted meat. So if you have a bowl of rice, this rice is in equilibrium, very balanced, it's in equilibrium. Now if you want to actually explain Chatellier's principle, don't ask a man or a guy to eat. Men don't know how to eat. They will just use the spoon and scatter everywhere. Some of them will even begin by eating the meat. But trust our sisters, they are wonderful people. Our sisters, they know how to eat. Our ladies, they know how to eat. They will remember that a lot of people may be looking at them, but men don't care anyway. Who is looking at me? Am I owing anybody? So if you ask one of our sisters to eat, one of the ladies to eat, you will see how they normally eat. They will just pick the spoon gradually. They will be taking some quantity of rice. They won't even open their mouth very wide. Yeah, so gradually. Now this spoon, remember, this rice is balanced, no side is falling. But the moment you introduce spoon, that's an external disturbance on this rice. So as you gradually use spoon to take some quantity of rice, you will notice that you have disturbed the rice. You will create a hole. Now what will happen to the rice on top here? What will they do? They will shift in order to cancel the effect of that constraint. What's the effect of the constraint? The hole created by the spoon. So the rice here will shift to cover the wall, the constraint. And that's what happens in chemical reaction. When a chemical reaction in equilibrium is disturbed by an external constraint, then the position of that chemical reaction will shift in order to annul or cancel the effect of the external world, the effect of the external constraint. Okay, now what can possibly be this constraint? That's the first thing we need to look at. What can possibly be this constraint? These constraints or these disturbances are the factors that affect a reaction in what? In equilibrium. That's what we mean by the constraint. So when we are talking about the constraint, we are dealing with factors like pressure, concentration, and temperature. These are the three main factors that usually affect a system that is in equilibrium. So these disturbances can be pressure, temperature, or concentration. They can be pressure, they can be temperature, they can be what? Concentration. So when you say, the Chatellier's principle states that if an external disturbance, in other words, the disturbance can be what? Temperature. So if it is temperature that is coming to disturb a system in equilibrium, definitely the equilibrium position will shift to cancel the effect of that temperature. We are going to see that, how that happens in a reaction. But before then, because that will be in the next part, that's when we'll start looking at the effect of these factors on what? On a system that is in equilibrium. But before that, we made a statement in this particular principle. We talk about the equilibrium position shifting, adjusting. So now when equilibrium position shifts, it can either shift to the right or it can shift to the left. So shifting to the right means moving to the forward direction. Shifting to the left means moving to the backward direction. So the equilibrium position can shift to the right. We have to note this. The equilibrium position can shift to the right. So let's note the following. So when we say that equilibrium position shifts, where is it shifting to? You know, in a reaction, we have A plus B. Let's continue to use arbitrary reactions, C plus D. So if we have this, now if the equilibrium position is shifting to the right, it means it's moving forward. So it can also shift to the what? To the left. So what will determine the direction the equilibrium reaction will shift, as the equilibrium position will shift, depend on the nature of the what? Of the constraint, and also on the nature of the reaction. So that's why when we start looking at these factors, we'll now see how concentration affects equilibrium position. Because someone will say, oh, concentration will shift it to the right. No, that's not a rule. It's not a rule. But we have a way of explaining how concentration will affect a system that is in equilibrium. So when we talk about the shifting, it can either shift forward, that's to the right, or backward. So let's note the following. Equilibrium position can shift to the right or to the left when equilibrium position shifts to the right, the forward reaction will be favored. Thus, production or generation of more products will be favored. So when equilibrium position shifts to the right, we have said that it can shift to the right or to the left, but when it shifts to the right, it means the forward reaction will be what? Will be favored, yes. And when forward reaction is favored, it means more products are generated, because that's the product. The forward reaction will be favored, more products are generated. So if you want to generate more products in a given equilibrium reaction, it means you need to introduce a disturbance that will shift the equilibrium position to the right. So whatsoever thing that moves the equilibrium position to the right will eventually help in doing what? Increasing the yield of product, that is generation of more products. Very important. So number 3 now, when equilibrium position, I omitted position here, so it's important. When equilibrium position shifts to the right, yes, when equilibrium position shifts to the left, the backward reaction will be favored. The backward reaction will be favored. Thus, less products will be formed. So we must understand this. So when we talk about equilibrium position shifting, it shifts to the right or to the left. And there are factors. These factors we have mentioned: pressure, temperature, and concentration. They are the factors that will always make the equilibrium position to do what? To shift. So there is a way temperature will enter a reaction. Yes. It will make the reaction to shift, the equilibrium position of the reaction to shift forward. That's to move to the right. There is a way temperature will also enter a reaction. Instead of making the equilibrium position to shift to the right, it will make the equilibrium position to shift to the left. There is a way pressure will enter a reaction. Instead of making the equilibrium position to shift to the right, it can also make it to shift to the to the left. So each of these factors, pressure can move equilibrium position to the right and can also move it to the to the left. The same thing applicable to temperature. The same thing applicable to concentration. So you cannot say that concentration will always move it to the right, no, or pressure will always move it to the left, no, or temperature will always move it to the left, or will always move it to the right, no. Temperature can move equilibrium position, can adjust equilibrium position to the right, can also adjust it to the left. Likewise concentration, and likewise pressure. So we are going to end the class here. At least you know what we mean by Chatellier's principle, and you now know what we mean by the equilibrium position shifting or adjusting. Very, very important that you understand this, so that when we start looking at the factors affecting a reaction in chemical equilibrium, then you'll be able to understand it more. Thank you for watching our video. If you have not subscribed to our channel, please do so. Very, very important. There is need for you to do so now. And also share our videos so that we can reach other people. Thank you. I still remain your friend and your brother, and also your tutor, Engineer I. I love you.